What we need to determine is what our genotypic and phenotypic ratios are. So just as a reminder, the genotype is the actual genes of the organism. So these letters here represent the genotype of the organism. And the phenotype is the actual physical characteristics. So brown or white, the physical characteristics. So, as you saw on the slide, the genotypic ratio is equal to the number that are homozygous dominant, or HOMDOM, the number that are heterozygous, and the number that are homozygous recessive. So in this example Punnett square that I've done, the number that I have that are homozygous dominant, so big B, is 1. And then the number that I have that are heterozygous, big B, little b, is 2. And the number that I have that are homozygous recessive is 1. So that means that my genotypic ratio is 1 to 2 to 1. I'm counting up the number of genotypes that exist in this Punnett square. Phenotypic ratio is just a little bit different. It's the number that show the dominant trait. That means any of them that have that dominant trait, in this case, brown fur. So how many is that? This one is going to be brown because it's got 2 dominant alleles. And then these 2 will be brown as well because each of them has 1 dominant allele. So that's 3. And then it's the number that show the recessive trait. And here, we only have 1 that's going to show the recessive trait. The only way to show the recessive trait here is if the organism inherits 2 copies of that recessive allele. So our phenotypic ratio ends up being 3 to 1.